So I'm going to test my algorithm out with phosphorus 4, and that has a structure like a tetrahedron. So one of the graphs I obtain should be the same as this here. So if I run this code, I'll get, this is my first graph. But there's something strange about my first graph, because this graph, if you count the nodes and edges, is not the same as this. It's a different graph in a mathematical sense. The reason why this is not an isomer of phosphorus 4 is because in physically it won't work because of the angles made by each atom. So my program, one of its limitations is that it only generates the graphs based on if each atom's valences are balanced. So this is physically impossible, but this is a mathematically valid graph. If I look at the second graph by closing this window, I get this. If I track each edge and each node, you will find that it's the same as this here, just reordered in a different way. So there's one real isomer, structural isomer of phosphorus 4, and there's one graphical mathematical one, which is not true in a chemistry sense. So now I'll try another molecule, which is alcohol. So it's C2H5OH, and the isomers of that is this. So there's 2 carbons, 6 hydrogens, and 1 oxygen, and I've defined that here and I set it to alcohol. So if I plug this into my algorithm, it should give me my 2 graphs. Okay, so this is the first graph. Let's see which one it corresponds to. So each carbon has 3 hydrogens, which is true for both of these isomers, but this one has an oxygen in between the 2 carbons. So I know it's dimethyl, I can't pronounce that. I know it's the one on the right though. So that's one structural isomer. Now let's see if the graph generates this one. So this graph, each carbon has this carbon has 3 hydrogens, and this carbon has 2 hydrogens, which is true here, so 3 and 2. And this carbon branches off into an oxygen which has a hydrogen. So this carbon branches off into an oxygen which has a hydrogen. So that was my demo of my code. I hope you enjoyed it.